Okay, guys, so today we're going to take a look at actually solving exponential equations. Okay, so some of the success criteria for today is going to be able to take what the bases for each side of the equation and write them the same. Okay, so that's kind of, we need both sides to be x and x, except today we're going to deal with numbers. They're not going to be necessarily variables as the base, as we have been, where we've been applying our power laws, right? So if we had something like this, that would have turned into x to the 5, right? So the base today is not going to be a variable. It's going to be numbers, okay? So that's how today is going to change. So with numbers, we're able to make them match or manipulate what's going on, okay? And then being able to solve the equation. So you can see how we've dealt with two kinds of functions or equations so far, right? We had linear equations where we were able to solve for x directly by just moving stuff around. So it would have gotten 4x is equal to 16 here, right? And then x was going to equal to 4, right? Here, to solve, right, we factored to solve quadratics. And we got x is equal to and x is equal to most times, right? We got two answers, okay? Today, solving exponentials is a little bit different and probably more fun than, or more satisfying than actually doing the factoring or just factoring, because we're going to actually implement some of our linear equation solving methods into solving exponentials, okay? So an exponential equation is an equation where the unknown is in the exponent, okay? So you can see that here. The unknown is in the exponent this time, okay? And then the key to solving this type of equation is to establish a common base. So that just simply means let's make the base on either side equal before I can do anything. That's step one, okay? So if two powers are equal and they have the same base, then the exponents must be the same, okay? Now, that's a whole bunch of math language. It makes a little bit more sense once you start seeing questions done, okay? So step one. Let's start here and we'll go to example one, okay? So is there a way, your job is to make the bases the same. You can see here the bases are not the same, but your question is there a way for you to make 32 into 2? So can I That's your question. So you're going to rewrite the left side of this. It's going to be 2 to the x is equal to. You need it to be 2 in order for this to work. You need the bases to match. Then your question is there an exponent that I can put up top here to make this 32? Well, turns out that if I put 2 to the power of 5, that's equal to 32. So now that the bases match, right, you can go to step 2 here. Since the bases are equal, the exponents must be equal. So here are your exponents, right? So therefore, in this particular question, x must equal 5. Okay, and I could check that being true by taking it and plugging it back in for x. Okay, that should equal the right side. So let's do the next one. If I have, I'm going to rewrite the left side, 3 to the x plus 1 is equal to 3. I need it to be 3. Is there a way for me to write 3 to the power of something to give me 81 is my question. Turns out that it's 4. Okay, so it's 3 times 3 times 3 times 3 should equal 81. Okay, at which point you're able to go, okay, the bases match, make the exponents equal, solve for x, like a linear equation. So x is going to equal to 4 minus 1, which is equal to 3. Okay. And again, if I were to plug that back in for x, you would get a 4 in the exponent, 3 to the power of 4 would equal 81. Okay. So let's try next one. I need to x minus 1 is equal to 2. I need it to be 2. How do I get 4 from 2? Square it. And then x plus 1. Okay, so the catch with this question is you have a little expansion to do in the exponent before you can do anything. Okay, so you're going to land with, actually, you know what, now that the bases are the same, we could just simply go x minus 1 is equal to 2x plus 1. Expand. Okay, solve for x. So I'm going to go, I'm going to bring the x over to the other side. So I'm going to go -1 minus 2, okay, is equal to 2x minus x, okay? And so I'm going to get x is equal to -3, okay? And that should give you back, if you plugged in -3 here, it should be this, the sides should equal, right? So it'd be 2 to the -4 should be equal to 4 to the -2. Okay, it should be equal when you check that. Okay, so let's keep going. Okay, let's try this one here. 3 to the 4x minus 1. How do I get 9 from a base of 3? I square it. And so make the exponent, this is step 1 is make the base. Step 2 is going to be check the exponent. So it's 4x minus 1 is equal to 2. Solve for x. So in this particular question, we're going to go 4x is equal to 3. So x is going to equal 3/4. Okay, you can see how you can get some, you'd never be able to maybe figure that out as a decimal, just plugging in, like guess and checking. I don't think you'd be able to figure that out. This is a method to actually solve for the exponent, right, directly, exactly too, right, no decimals. Okay, this one here, this is much like question C. Okay, I can go 4 to the 5x minus 3 is going to equal to 4 squared, should be equal to 16x plus 1. Exponents are now equal because the bases match. I can go 5x minus 3 is equal to 2x plus 1. Solve for x. So I'm going to get 5x minus 2x is equal to 2 plus 3. Okay. And then I'm going to end up having 3x. I'm going to move this over. I'm running out of room. (3x) is equal to 5, and so x is 5/3. Okay. Now I can rearrange f to be 5 to the 2x minus 1. I'm going to apply, I'm going to make this 125. Okay, to the -1. Okay, and then what I can do is match the bases. Okay, so I can go 5 2x minus 1 is going to equal 5 cubed multiply, or like to the exponent of -1, right? So these are going to be multiplied together, right? And so I'm going to get 5 to the 2x minus 1. Well, actually, we don't need the bases anymore because they now match. So I can go 2x minus 1 is equal to -3. And then so 2x is equal to -2. And x is going to equal -1. Okay. We can keep going. Okay, so the same question here. You're going to bring up the denominator. Okay, So it's 4 to the x plus 3 is equal to 1024 to the exponent of -1, because I've brought it up. Okay. And your job is to figure out that 4 to the x plus 3 is now equal to 4. What exponent is going to give me 1024 on 4? It's going to be 4 times 4 is 16 times 4. Is it going to be 4? We can check that. Okay, so let's check. Let's go calculator. What is it? It's 5. It's 5. So you gotta go 4 to the power of 5 will give you. And remember, it's multiplied to the -1, right? It's not 4, it's 5. Okay, so it's 4, and then this is multiplied to the -1, right? So you can now eliminate the basis. It's going to be x plus 3 is equal to -5. And so x, when I solve, x is going to equal -8. Okay. Now, be careful with this. Okay. A lot of people want to do this right off the bat, and it's wrong. You do not expand that. Okay. Okay. Particularly because you have to deal with the exponent before you can do any multiplication, right? That's what BEDMAS says. But I can do something if I were to, if I divided both sides by 3. This gets a lot of people. Now the bases match. And it's 5 to the 1. So x is actually going to equal, x plus 1 is going to equal to 1. So x is equal to 0. Okay. This gets a lot of people. Do not expand it. Okay. And then this one here, you have an exponent of 1. Bases match already. Okay. So what you can do is go 3x plus 1 is equal to 1. Okay. And then you're going to end up with 3x is equal to 0. So x is equal to 0. Okay. And that's it, guys. So 100% about this. Okay. First step, make the bases match. Okay. 2, solve for the variable. Actually, it's make the exponents equal and solve for the variable. Okay. And 3 can be check to see if you're right. Okay. That's it, guys. Kind of a fun solving method. Could be a little bit tricky sometimes, but overall, probably one of the more satisfying solving methods that we have.